Welcome back to our outdoor series. Today we're going to be talking about plankton. We have done a webinar on plankton as well, but this is going to be a brief introduction to the base of the marine food web. Again, those are the plankton. Plankton, simply put, are the ocean drifters. They are anything in the ocean that goes with the flow. If you can swim against the current, we define you as nekton. So again, we're going to be talking about plankton. There are two types of plankton that we focus on at OPAC. There are phytoplankton, which are the plant plankton, and there are zooplankton, which are our animal plankton. The phytoplankton, they photosynthesize, and they actually produce more than half the oxygen that we breathe, and they are also the base of the marine food web, so everything else relies on them. I like to call phytoplankton the grass of the ocean, because our zooplankton graze on the grass, kind of like cattle do on our terrestrial systems or on land. And when the zooplankton, when they graze on the phytoplankton, they become what we call primary consumers, and then everything else in the ocean relies on those zooplankton as the start of the marine food web. So again, we have the phytoplankton. They are producing our oxygen through photosynthesis, and we have our zooplankton, which are our grazers. All of our phytoplankton, they are microscopic, so we need a microscope to see them. But our zooplankton, their size is pretty dramatic. They can be super tiny where we need a microscope to see them, and then we have large species of jellyfish and some larger shrimp that are also zooplankton. Again, ocean drifters, things that go with the flow, that we don't need a microscope to see, but they are still considered plankton. So some zooplankton, they spend their entire life cycle as zooplankton, and then other zooplankton like fish and crabs, they start their life cycle as zooplankton but then evolve into what we think of them as the larger crustaceans or fish. Fish start off as eggs, so they're all zooplankton for a short period of their life. We are filming this little segment about plankton at our headquarters in Plymouth, the Center Hill Preserve, which is really awesome because we can actually go down to Cape Cod Bay right behind me and we can take a plankton sample, which is really fun. If you watched our plankton webinar, you saw us do this back in March. It's warmed up quite a bit, so we're excited to get back in the water and do another plankton tow. Also stay tuned because after we do our plankton tow, we're going to go back up to our classroom and I'm going to show you the two different types of microscopes that we bring into the classroom to look at plankton, both phytoplankton and zooplankton. And then when we're done with that, we're going to do a quick art project where you actually get to make your own plankton. Alright, so if you've tuned into our past videos, you've seen us do a plankton tow before, but it is starting to warm up now that it's springtime, and that is allowing all the nutrients in the water to have some great plankton blooms. So we're gonna go out again and try and see what we can find. If you're not familiar, this is our plankton net. It has just a small opening for us to tow behind us. All that is going to be filtered through some very tiny holes, fine mesh in our plankton net here, all the way up to our cod end jar. And the cod end jar is our collection container, and then we will take our sample back up to the classroom and see what we found. So the first thing that I want to do when I am collecting my plankton sample is just fill up the cod end jar. That'll allow it to sink down in the water column a little bit and hopefully not catch all of the debris floating on top right here. Alright, our cod end is full. Alright, now that the cod end's full, you can see that I'm just trailing the plankton net behind me here. See it there? Alright, as I expected, our sample is very cloudy or turbid, as we learned from our water quality lesson. And that has to do with the fact that where we're taking our plankton tow is a very high energy zone. So there's a lot of wave action right now, and what that's doing is churning up the benthic zone, the bottom of our water column, the ocean floor, and that's just sending up the debris and the sand and the mud that's down there. And we are going to get some of that in our sample, but that's kind of cool because there are plankton that live down there too. Hello everyone, welcome back. We are in our classroom at the Center Hill Preserve. I have our plankton sample here in one of our Earth Echo kits that we learned about the other day in our water quality short outdoor series video. So we have our plankton sample, And before we take a peek at it, we need to learn a little bit about the instruments that we are going to use, or the tools that we are going to use to see the plankton that we collected. There are two different types of microscopes here that we are going to use. And the first one is called a compound microscope. And a compound microscope is great for looking at small microscopic things like our phytoplankton, because we can see down to individual cells on our compound microscope. So this is really good for looking at things when we need a high magnification, when we really need to zoom in. So think about those tiny phytoplankton. And then over here, we have our dissecting microscope, also called a stereo microscope. Yeah, the dissecting scope is great for looking at our zooplankton. The dissecting scope is also wonderful because we can see live organisms. So now that we've learned a little bit about the instruments that we're going to use, I have, again, our plankton sample right here. And what I'm going to do is prepare a slide, which I have right here. And then I'm going to put a drop of water or two on our slide. And then we put the slide cover on top of our water droplet, and just make sure that we don't have any air bubbles in there. Okay, so now that phytoplankton sample hopefully is ready to go. And then I have a petri dish here, which is wonderful for looking at our zooplankton in our dissecting scope. And we are going to put our sample, we can take a little bit more on our petri dish, and then we can take a look at that under the microscope. So the first microscope we're going to look at is our compound microscope. We are going to be looking at 100 times magnification, so everything we are looking at is 100 times smaller than it appears on our video. This is a little tricky here, but what you're seeing is a centric diatom, that little tiny green dot. Alright, so we've moved over to our stereoscope, or our dissecting scope. As I did mention, you would see some of the debris there that we had because it was a turbid sample. Now we're looking at a copepod. They move really quick. They can jump 500 times their body length. There's also some centric diatoms in there. That's a polychaete worm entering our sample now. They're really cool. They're one of our benthic creatures that we caught in our toe. There's also some more copepods swimming around, and here is actually a barnacle larva, which we also had in our plankton webinar. Our OPAC students also get to do their own plankton toes. So we're going to do this quick art activity that we tend to do in our plankton and plastics workshop when we're in the classroom. So we thought we'd bring it to you virtually today. So what we're going to do is we're going to make some Suncatcher Diatoms. Our Suncatcher Diatoms are going to be representing our phytoplankton, the plant plankton. Diatoms are made out of silica, and they're often circles, and we call these centric diatoms. So we've come up with this activity where we make centric diatoms out of biodegradable materials. This is a coffee filter, so this is what you'll need to start off with flattening out a coffee filter. You can stick it under a book or something overnight. So coffee filters are great, again, because they will not hurt the ocean if we throw them out. They are paper, they will biodegrade. So the first step, again, flatten your coffee filter so that we have a centric diatom shape. Once you have your flattened diatom, what we're going to do is fold it into quarters. And the reason we're doing this is because diatoms have symmetry. And symmetry means whatever you have on one side, you have on the other. So we're going to fold this into quarters so that whatever we end up putting on our diatom will end up in every part of it. The other supplies that you will need today are some watercolor paints and a paintbrush and some water, and that's it. The reason that we call these Suncatcher Diatoms is that once they're all done, we can hang them up in a window or make a mobile out of them, and they will catch the sun just like diatoms do in the ocean when they're photosynthesizing. And yeah, so we're going to start by just getting our paintbrush a little bit wet. I had mine sitting here in the water already. You do need to use enough water so that it saturates through all the layers of your folded coffee filter. Otherwise, what you did on one side won't happen on the other side, which is okay. You can fill it in later, but the idea is to make it easier for you. So let's see, I'm going to wet some of my paints here. I'm going to try and make my diatom kind of similar to the picture that I want to show you. So I'm going to start off by getting a lot of green on mine. I'm going to do some big layers of green watercolor paint here. Alright, so now that I've fully painted my diatom here, you just want to open it back up and let it dry. And then once it is dry, you can hang it up. And I encourage you to share your diatoms with us on our Facebook page, or you can send us an email through our website. Our website is www.opakedu.org. And these are what your Suncatcher Diatoms can look like when they're hung up. We love plankton, go with the flow. Some are big and some are small, but we don't care, we love them all. They provide the oxygen we breathe and the food the ocean needs. We love plankton, go with the flow.